Okay guys, let's look at the test review, looking at the questions. First question said, what is the average speed of the car in meters between point B and point Q? Gotta remember, average speed is distance over time. So all you have to do is come up here, look at the distance from point B to Q. Its original position is at 15. This is 30, so that's 15. Notice the units is in kilometers, so that's 15 kilometers per 30 to 90, so that's 60 minutes. So when you come down to find your solution, you notice that this distance was 15 to 35 B to Q, so that's 20 kilometers, which is 20,000 meters. How many seconds are there in 1 hour? Since it was 60 minutes, it's 3,600. So we just did a straight division, got 5.56 meters per second. Do not forget that's your units. Question 2. Car moving along a level road increases speeds from 18 meters to 35 meters per second. I know that's important. So that's probably going to be my initial velocity here. My final velocity was 35 meters per second. My time was 9.5. It wants to find its acceleration, average speed, how far did it move while accelerating. Everything is in the x direction. We're going to put our big 6 down here. For some reason I put an extra xf. You can ignore that. So I'm just going to go ahead and edit this document while I'm right here. We're going to go ahead and kill this right there. But you know your x naught was going to be what? Should have been 0 equals 0. Don't know what's going on with that. That just looks a little ugly, but that's okay. My x naught should have been 0 meters per second, since that's my initial position. My initial velocity was 18. Final velocity was 35 meters per second. Acceleration didn't give me anything. So I need an equation that does not have a acceleration to find the acceleration. I simply plugged in 35 equals 28 plus 8.95, subtracted 2 divided by 9.5, came up with that answer. It says where's the average speed? I know speed is distance over displacement over time is average velocity, but they want to know the average speed, which is the same thing here. I just made a typing mistake. That should have been speed. And we know that is simply what? Distance over time. So but it so happened to turn out to be the same thing. Remember, the symbol for average speed is a V with a bar above it. I found my distance to be 204 since my initial displacement position was 0. 204.39 divided by 9.5 gave me an average speed of 21.52 meters per second. How far did it move? We found the distance. We used that to find the average speed, 9.5 seconds. Next problem. A man travels north. I think this was the hardest one because we're forgetting that this has to be a Rx or Y problem, and I will write that up in those terms in just a second. But I wanted you to understand was where my calculations came from. Find his average speed, average velocity. Speed, we had to find distance. Average velocity, we had to find displacement. So you know with distance, we converted that 33 divided by 60, 33 minutes into 0.55 hours. That way I can take the 0.55 plus 2 hours to get 2.2 hours. If I'm going 65 miles per hour at 2.2 hours, I know I'm going 143 miles. I came back, got the 44 minutes over 60 seconds. Let that be 0.73 hours. We're traveling at 65 miles an hour. So that should have been 65 miles an hour. So So let's go ahead and correct that right here really quick. That should have been for 65 miles an hour. See how much is that's going to change on the handy dandy calculator. 65 times 0.73 make that 47.5. So this number here becomes 47.5, which makes this 190.5. Right? So now we're going to take that distance, change this to 190.5 divided by that time. Bring up the calculator again real quick, see what we get. I have 190.5 divided by 0.73 right here at the bottom. So we know that 0.73 was 43.8 was 47.5. 47.5, which gave us 190.5 miles. So that becomes 190.5 miles divided by how much time we had total. 0.55 hours plus, that was actually 2.2 hours plus 0.73 divided by 2.93 right here. So that gives us 190.5 divided by 2.93. That gives me 65.01. Okay, let's try that again. I have 190.5 divided by, my total time was 2.93. Clear that. 190.5 divided by 2.93. That should give me 65 miles an hour. For the average speed. Okay, back to where I was at. I wanted to make sure you understood that I calculate the miles 143, calculate the miles 47.5, total miles 190.5 miles. We take the distance total 190.5. I got 2.2 plus 0.73 hours, 65.02 miles per hour. Multiply that by 0.621, got 40.38 kilometers per hour. Divided by 0.36, got 11.27 meters per second for his average speed. Average velocity is displacement over time. So we had to take the dx, which is the x distance, and the y distance, that's the components for each one. Add them up, take the square root of the square, it's got 150.67 miles times 0.621 gives me 92.877 kilometers. We know we want two decimals, 92.88 kilometers. I went ahead and hit that with 1,000, gave me 92,800 divided by 3,600 seconds in an hour times 2.1 hours. And then I divided those two, got 12.275. That 2.1 hours really should be 2.2 hours for that total, 2.7 hours, 2.75 hours for that total time. Okay, so if I wanted to fix this to be proper, I would multiply this by 2.27 to get the exact answer. Let's see what that would be on the handy dandy calculator. For the sake of time, I'm curious. So I'm going to take 92800 divided by open parentheses 2.7 times 3600, close it, equals 8.8. I don't think it should have changed it that much. Let's go back here. That's 2.93 hours. 2.93 hours. 2.93 hours times 3600. That's how many seconds we got. 10,548. 10,548. 92800 divided by 10,548 gives me 8.79 meters per second. So I guess this number right here would change to 8.79 meters per second. Come back down here. We know that's the magnitude. Here comes the angle, which is Ry divided by Rx, 143 divided by 47.5. The angle is 71.64 degrees. I'm going to do one quick check over here to confirm that number. Let's multiply this right here by 2.93. So this guy right here should be 2.93. Yep, 8.79. So that changes this to 8.79, 8.78. And you know that's going to be at south of east, because he first went what direction? North, then he turns right and travels 44 minutes towards the west at 65 miles an hour. Should have said turn to the right and travel 44 minutes towards the east, which puts his vector at a angle that is up north of east, northy. Cool. I'm gonna draw that problem up so everybody can see what we're talking about there. I'm gonna paint real quick. Actually, I'm going to go what I use is a program called let's go to paint just to make a point real quick. Jump down here to accessories. Let's go to paint. You know he's going north, then he went east. Here's your final vector, which is pitiful, which tells me that my angle is right here. That's my theta. So that is north of east. Okay. Next problem says, let's find it. Number 4 says a plane starting from rest at one end of the restway at rest is crucial. X naught is what? 0. And my V naught is what? 0. So I should have been able to put those in right there. Okay, that should be 6. Okay, accelerates at 1.7. That's my acceleration for a distance of 1.5 kilometers, which really makes that what? 1,500 kilometers, right? So we know we should have a what right here. Let's see one that's being crazy. Let's stop editing that for a second. Let's simply do this. Let's add text. One right there, that should be 0 meters. We know that should be, sneak it right there, 1,500 meters. And you know starting from rest means that this guy right here has to be 0. Meters per second. Okay, that zero's in a bad spot, but it's the point. at 1.7 meters per second squared. So I'm looking for what is the speed upon takeoff. I'm looking for that takeoff speed. I've got some V naught, which goes to 0 because he started from rest. So that's trash. You know you have acceleration 1.7, your distance is 1500. Multiplied that, took the square root, got my answer 71.41. Next question is, how long did it take the acceleration to take off? Keyword there is what? How long? We know we're looking for time, which I've already moved back in there. This time is not related to this problem. So now I'm going to put my time in here. Looking for time, I'm going back to the first equation. X naught went to 0. V naught went to 0. I have 1/2 AT squared. Plugged in my numbers, took the square root, got 42.01 seconds. Next problem, you have a child that's rolling a ball down a hill with initial velocity. It has some initial velocity, 4.29. Put that in my big 6. Accelerates down the hill, has some acceleration. How long would it take? You know, we're looking for question mark. And my distance is 235 meters away. How fast is it going at the bottom, which means we're looking for the final velocity. I'll plug into the second equation. I have some initial, I have some acceleration. I did the math, squared that, took the square root. My answer is 42.86. Next equation says VF equals V naught plus AT. Love that baby equation. Since I just found the final velocity, I know the initial velocity, solve for T. Number 6, polar bear. Lots of words, don't get intimidated. The bear dives into the water and begins swimming with a speed of 2.60. Initial velocity. His speed decreases to 2.20 by the time he gets to the shore. So that means that is his final velocity. It's got some acceleration there somewhere. If the polar bear swim time takes exactly 90 minutes, so right off the bat, I multiplied that by 60, got 540. Looking for how far he traveled, X naught is 0, V naught plus VF divided by 2 times 440 for the time, give me 1,296 meters. Number 7, surprised me, a lot of people miss this question. You got to go back to the definitions. It tells you what to do. The question says, calculate average velocity. Velocity displacement over time. Displacement is what? Final position minus initial position. This is the position scale over here. So his initial position was what? 0. His final position was 0. His initial position was 0. So you know that 0 minus 0. Don't really care that it took 20 seconds. But then at the bottom, you have 0 meters per second. Don't miss the easy ones. Number 8, starting at a certain speed, bicycle travels 200 meters. That's his distance. Oops, let's undo that. His distance is 200 meters. You know his original position is 0. Suppose the bicycle undergoes acceleration of 1.2 meters per second. 1.2 meters per second. If the final speed is 25 meters per second, what's the initial velocity, speed? So we're looking for what? V naught. V naught don't have a time, should be third equation. Plug in the numbers, got to some algebra. We have 625 divided by 200, take the square root, 1.77 meters per second. Number 9, an automobile that set the world record for acceleration. It's increased speed from rest to 96 kilometers per hour. Right off the bat, I see from rest, that's 0. I see 96 kilometers per hour. So I'm going to convert that to what? Meters per second right off the bat by dividing by 3.6. My time is 3.07. How far did the car travel with the initial speed? I know I'm looking for X of F. Plug in my numbers, straight calculation, 40.94 meters. What is the car's acceleration? I now can use baby because I have some VF, I got some V naught, I got some AT. Boom. Stick in the calculator, divided 8.6 meters per second squared. So that's the test. Review is this is the solutions. Retest, you want to make sure you go back and look at problem number 3 and show that Rx, Ry composite components, plug them in so you can get the what? Displacement is always what? The Pythagorean theorem. Right now everything is in X, everything is Y. Thanks.